welcome, good morning, good afternoon, good evening, and thank you for joining today's webinar on intercanopy lighting and its role on maximizing cannabis yield and quality. My name is Tim Kopp with Fluence Marketing. I'm thrilled to be your moderator today as we dive deep in what's becoming an innovative lighting strategy that's poised to revolutionize controlled environment cannabis cultivation. We know that intercanopy lighting can be a potential game changer, delivering light directly to the lower canopy to enhance photosynthetic efficacy, improve plant health, and optimize cannabinoid and terpene production. Today, we'll be breaking down the science behind how you utilize these strategies, and we'll explore the best practices for integrating this technology into your operations. Whether you're a commercial cannabis cultivator, facility manager, or home grower looking to optimize your yields, this session is designed to provide you with data-backed insights that will help you make informed decisions that potentially can take your cultivation efforts to the next level. With us today and leading the discussion is Dr. David Hawley, Principal Scientist here at Fluence. Having received his PhD through the University of Guelph in Ontario, Dave and his team of cannabis crop scientists have become pioneers in the field, spearheading cutting-edge research on horticulture lighting, controlled environment systems, and cannabis cultivation. With his extensive expertise, Dave will guide us through the intricate relationship between light and plant development and share his insights from his team's industry-leading research. Speaking of the team, today we have Dr. Jason Matlock and Brian Pohl, they'll be assisting us in the Q&A portion at the end of the session. So why don't we get started? Just a reminder, as we go through today's presentation, I'd like to invite everyone to submit your questions by clicking the Q&A button that you should see at the top center of your screen. We'll be leaving plenty of time at the end of the session to answer as many questions as we can. We'll also be making this recording available in the next couple of days, so don't worry about screenshotting or anything like that. Just sit back and enjoy the show. And so without further ado, let's dive in. And Dave, the floor is yours.
All right. Thanks, Tim. And wow, we did not give me such a flowery introduction in the rehearsal. So I'll take it and thank you. All right, everybody. So Tim has indeed introduced me. My name is Dr. Dave Hawley, and I head up R&D and our cannabis science and hort services team. So the intent of this presentation, if you've seen me present before, you probably know what kind of flavor of presentation you're in for. My goal is always to demystify cannabis lighting technologies and then ultimately leave you with a fairly clear sense, hopefully, of whether or not a given technology is right for you. And so the way I have today's presentation set up is that I'm going to be touching on these 5 big categories. So first of all, what is ICL? Chances are, if you clicked on the link for this webinar, you already have a pretty good idea of what it is, but I want to get us all on the same playing field from step 1, and we'll go from there. And then I want to dive into just right away, what do we think the realistic benefits are or not of ICL, which, I'm going to say ICL, I'm going to say SCL, I'm going to say UCL. Those stands for intercanopy lighting, subcanopy lighting, undercanopy lighting. You're going to hear them a lot. So get used to that. But again, what are the benefits or not? And then we're going to talk about what the right spectrum may or may not be. And we're going to talk about the pros and cons of intercanopy versus undercanopy light right here. And then finally, the category that I think is kind of the most fun to talk about is why there seem to be such mixed messages in the market about whether or not ICL or UCL really add any value to your crop. So without further ado, let's just dive right in. Intercanopy lighting. What is it? Why would you care about it? Well, when we talk about intercanopy lighting, it's in the name. It's quite literally just taking light and sticking it in your canopy. You've probably seen this on trade show floors as long kind of tubular lights or other form factors. So, pretty straightforward in understanding what is. But a better question is why? Why would you do this? And the answer is simply that you want to be putting light onto plants as efficiently as possible. And it doesn't matter if you're talking about cannabis or lettuce or strawberry or cucumber or tomato. The name of the game is the same. Your leaves on plants are functionally kind of like solar panels. And it's kind of like if you bought solar panels for your house. If you buy a whole bunch and then you don't put any light on them, you have wasted your capital investment. Growing leaves on your cannabis plants is the same idea. If you grow a lot of leaves that aren't really seeing a lot of light, they may be just doing nothing, and that's wasted investment. You paid for those nutrients, and you paid for that water and CO2 that went into making those leaves. So make them work for you to grow more bud to make you more money. That's the rationale. Having said that, there are things you need to consider beyond just trying to put more light down in the canopy to have the plant be more efficient. Let's consider a cucumber crop. And the picture that you see here on the right in the top is a cucumber plant. And if you've ever been in a cucumber greenhouse, you walk in there and you see these walls of plants in what they call like a high wire system. The plants grow this vine that's maybe like 15 feet tall. And there's supplemental lighting at the top and there's sunlight at the top. But if you walk in between those rows of plants, it's shadowy. Like there's so much vegetative tissue that those lower leaves aren't really doing much. And what's more is that cucumber isn't really as light hungry as cannabis, meaning that those upper leaves are much more likely to get photosynthetically saturated than those lower leaves. So for a whole lot of reasons, putting intercanopy light in a crop like that makes a lot of sense. You have a shadowy area that could be adding value to the crop versus a part of a canopy that's already photosynthetically saturated. That may not be the case with cannabis. And by the way, Tim, if I can ask you to mute yourself, we're just getting a little bit of background noise. Thank you, sir. Not a problem. Okay, so to recap, cannabis might not necessarily respond to intercanopy light in the same way that we see these high wire vine crops like tomato and cucumber. Let me put that to you a different way. If we look at these graphs here, if you look at the top right, this is the photosynthetic response curve of cucumber. And what you see here on the x-axis is ppfd, or light intensity. And what I'm illustrating is that around 250 micromoles per meter squared per second, the relative yield that we're getting out of that crop is pretty close to this point of diminishing returns. In other words, even if you went up to like 350 micromoles, the part of the canopy that's seeing that much light is basically saturated and you're not getting anything back for your additional light that you add. Cannabis is a different story, right? As maybe a lot of you know, there's this one-to-one relationship with light and yield. 1% more light gives you 1% more yield up until this point of plateau. And with cannabis, that plateau is really high. I'm not going to go on and on about our past research from 2020. Suffice to say, we know that cannabis can tolerate lights up to, or light intensities rather, up to about 2100 micromoles per meter squared per second. And you're still seeing a linear return on yield. Mind you, cultivation gets a little tricky when you're at those higher light intensities, but you can do it. And in fact, we've seen cultivars go up to 2,500 micromoles. At that point, we stopped doing the research at intensities beyond that because managing the HVAC got, well, hard. I'll put it that way. So my point is, if you're growing maybe around 1,000 micromoles per meter squared per second, then if you add light to that canopy, whether you add it as top light or whether you add it as intercanopy or under canopy, you may not necessarily be getting greater efficiencies than this one-to-one already, right? So it's like, okay, just because this works really well in some crops, it might not necessarily work as well in cannabis because it just likes light so much. So look, that's the theory. Now, what does the research say? We're going to jump right into the research by talking about what benefits we've observed, and I'm going to tell you how we got to those conclusions. And I'm going to do that by telling you about 4 things. First, I'm going to tell you about our greenhouse research, then our indoor research, and then our commercial case studies that are less scientific, but collectively, the aggregate data allows us to do this last column here called meta-analysis. And that allows us to tell you a generalized conclusion about what we see intercanopy and subcanopy doing. All right, so the first study, this was done at a facility called Anexo in the Netherlands. And for those of you that care about experimental design, it was 4 replicates in a kind of split plot design. Our treatments were either 100% supplemental top light in a greenhouse or this 75%, 25% split of total light energy, right? And that's going to be important later. So understand when I'm talking about these experiments, I'm usually talking about total photon flux rather than ppfd. Again, I'm going to elaborate on that a little bit later, but it is really important to understand we are keeping our total energy applied to the plant the same. And that's really important. So in this case, we worked at 2 cultivars. What we saw was that when applying the same total amount of light, The cumulative yield of dehydrated inflorescence was the same, which makes sense. And what you're seeing in this graph, by the way, is this orange bar and this green bar. The two of them are the first cultivar, which in this case we just call the commercial cultivar. And in the second pair of bars, we're talking about skunk. So one thing that's not illustrated in this figure is that we did have an elevation in bud grade, right? So even though the total yield didn't go up, the value of the crop still went up, right? Because this is a little bit regional, but different bud grades have different market values, right? Grade A bud has the highest market value. Grade B has the next highest value. Grade C could also be called larf, could be called trim, could be called waste. Suffice to say, if you can partition more of that biomass into higher bud grades, you make more money. So it isn't just about absolute yield in this case. Okay, in the next study, this was over at our facility, or our partner facility, I should say, Texas Original Compassionate Cultivation. Brian did this study, and again, here are our treatments. We had either 1,100 micromoles or 1,400 micromoles of top light, and then for intercanopy light, we either had no intercanopy or 960 micromoles of intercanopy light. And on the next slide, I'm going to take you through a figure that's a little bit more complicated, again, emphasizing the importance of thinking about total energy versus ppfd. Okay, here what you're seeing are a bunch of numbers on the x-axis. Okay, so let me talk you through what these numbers say. The first number in the grouping, in this case 1100, this is your top light intensity. The second number is your intercanopy light intensity, right? So in this case, we had no intercanopy light. And then this third number in the parentheses, this is describing total photon flux. Okay, so here in this treatment, our total photon flux was 3,352. If we compare these two middle treatments, this is the most interesting comparison. Here we have either 1,100 micromoles of top light and 960 micromoles of intercanopy light for a total energy on the crop of 4,312. Or in this treatment, we put the total energy all into top light with no intercanopy light, right? So these numbers are pretty close. You can compare 4,312 to 4,267. And lo and behold, what these bars tell us is regardless of how the light was distributed, if the same total energy is applied, then you get, again, basically the same yield. And if we look at bud grade in this study, here we go. If we look at bud grade, we saw that in this study, bud grade was actually unaffected. So essentially what we concluded was, okay, well, just if you want more yield, just use more top light and don't complicate your life with intercanopy. But we were also aware, this was a conclusion that was in contrast to the greenhouse study that we observed. So that's, just to exemplify the point of why you really shouldn't ever look to a single study to make some kind of conclusion, because there's so many other factors that affect the outcomes. You have to do a lot of research to come up with a generalized conclusion. And with that, I'm going to segue to the next slide here and tell you a little bit of the data that we saw coming out of our commercial case studies, right? And if you're not clear what that is, that essentially means that we've deployed intercanopy lights and top lights to our customers and had them do trials in their facilities with their realistic commercial operations. And maybe it isn't the most scientific experimental design, but if you do enough of these, then again, the aggregate data lets you do something called a meta-analysis, so you can make overarching conclusions. All right, so from those case studies, what we saw was, first of all, using intercanopy light does enrich harvest value, right? If we compare these two pie graphs, let me take you through it. The top is saying that if you use top light alone, this is your partitioning of bud grade. And I'll call out this value right here. We're getting 57% A grade bud. If we use top light and intercanopy light, then your A grade significantly elevates up to 62%. And we have less trim. All right, so that's thing number one. Thing number two is that we are increasing bud uniformity in terms of mass and volume. Okay, so to take you through how to interpret these figures, right here we're talking about normalized mass. And if you look at the blue bar, that's top light alone. And the width of this bar is indicating the variability around that median. The pink bar is showing that with intercanopy light, this box narrows a little bit. In other words, we have less variability around that midpoint. It's the exact same way to interpret the graph below it, which is volume instead of mass. So to recap, this is just saying you get more uniform bud throughout your canopy and throughout your plant if you use intercanopy in addition to top light. And last but not least, we just wanted to call attention to the fact that whether you use top light and intercanopy or top light alone, your average THC concentrations are unaffected. So you don't have to worry about that. Okay, now what about some more qualitative things, right? We just talked about yield. And in case the takeaway was unclear, it's basically saying that, if you're applying intercanopy light as like a redistribution of the same total energy, you don't necessarily get a higher yield, but you do elevate the value of your crop. Now, more qualitatively, we did see some other things that are worth knowing about. What we've seen in general is that when growers try to operate at higher PPFDs, they have more challenges with the crop related to kind of weird morphology issues. So like in this graph, we're saying, okay, up to maybe 900 or 1,000 ppfd, things are pretty easy. And then in this stage that, depending on your cultivar, this might not be necessarily that one-to-one linear return on yield. But again, things are still kind of easy-ish here, all things considered. But once you start getting up kind of beyond 1,500 micromoles, this is where we see people still having high yields, but more instances of peculiar crop morphologies. So here's just some pictures of things we've observed. The leftmost picture is just your standard cannabis morphology, but we've had instances of people saying that under high light intensities, they're having their plants re-veg, or they're seeing foxtailing. And we see less of this when people go to high light intensities, but they do it without just focusing on top light. They do it with a balance of top light and intercanopy or subcanopy. All right, so to recap all of that, first of all, does intercanopy light increase yield? This is maybe, and I say maybe because if you are adding light, if you already have a top light solution in place and you want to add light to that canopy and you don't want to do it by adding top light for some reason, then if you are adding light, then you will increase yield, right? Unless you are up at like a crazy PPFD already, but most people aren't. So if you're adding light, whether it's top light, whether it's intercanopy light, it's going to increase your yield. What about these other things? Is it going to increase bud uniformity? Is it going to increase bud grade? Will it prevent problem morphology? Yeah, absolutely. And those are the things that we see as the biggest value for intercanopy light. Because again, even if you're just using the same total energy, you're not adding light, you're just redistributing the same total light, you will probably get a better crop out of it. Will it improve your canopy? Will it improve your chemistry? Probably not. At least we haven't seen it. All right, so those are the benefits. Now, what about spectrum? And I'm just going to dive right in. In this study, we looked at 4 different ICL spectra. We had a BW4 plus far red. And if you don't know, BW4 is that it's like Fluence's white light that everybody puts in their cannabis crop because it works super well. We added some far red to it on the rationale that maybe we could do something with source sink carbon allocation because that's a thing in tomato and cucumber. I hate to spoil the results, but it didn't matter. We also tried BP6, which is roughly 60-ish% red. We tried DR9, which is roughly 90-ish% red, and we tried 100% red, which is 100% red. And what we saw was that across those spectra, yield was basically the same. So looking at that data alone, we'd say, okay, well, let's just make a thing that's super red because that has the best system efficacy, which means it has the lowest operational cost for you, which means that it makes the most value for your business. However, the reality is, as you may know from our past webinars, too high of red with cannabis induces photobleaching. And photobleached cannabis, although yield will be basically the same, and your cannabinoid and terpene profiles will be basically the same, bleached bud has really low market value. Consumers don't want their bud to look like this. So when it comes to spectrum, at the end of the day, we say, for one, it's cultivar dependent, which I know probably everyone's tired of hearing, but it's the truth. When it comes to considering your intercanopy light spectrum, follow the same considerations that you would follow for top light. Don't use too much red. These days, what we recommend for people is Fluence's BP6 spectrum. It's a really nice balance between good, reliable plant quality adding light to the canopy, but you get a slightly boosted efficacy versus using something like BW4. Mind you, BW4 also works super well, and it makes a really nice working environment, especially if you have BW4 on top. You just get this really clean looking environment. So you have to decide what's kind of more important to you. A slight boost in efficacy versus, frankly, a nicer looking workspace, in my opinion. All right, let's move on. So that was Spectrum. Now, intercanopy versus undercanopy, or subcanopy, whatever you'd like to call it. It means the same thing. It just means you're sticking your lights below the crop, pointing up. What's better? Well, here we've done a study. Once again, we had 1,200 micromoles of top light and the equivalent of 300 micromoles per meter square per second of intercanopy or subcanopy light. Again, I'm communicating it this way so it's easier to understand, but know that we normalized the study based on total flux rather than ppfd. And what we saw, which was pretty interesting, was that, in fact, subcanopy light or undercanopy light actually yielded 7.1% higher than intercanopy light. And to kind of put it in more general terms, what we are seeing is that whether or not intercanopy or subcanopy is better really depends on what's going on with the rest of your cultivation. Because again, like I said at the start of this webinar, it's just about delivering photons as efficiently to the leaves as possible. You have to think about what that means for your crop, right? So if you have a really, really dense crop and you have your plants spaced really close together, if you use an intercanopy light, that light may not have the opportunity to kind of penetrate through the canopy and get to all the different plants. Which I know may actually kind of sound weird coming from me or coming from Fluence, because we used to talk a lot about using a more white light for better canopy penetration. And the truth is, as our knowledge has advanced and we've done more research, the value of that is less profound as what we used to think it was. That's just the nature of science and learning more things. Now we're finding that with intercanopy light and a dense canopy, even if we use a white light, it doesn't penetrate very well. In situations like that, you're better off with a subcanopy pointing up at the bottom of your canopy, because that's entirely like a new sort of plane of photosynthesis. You get better uniformity that way. Conversely, we've seen some growers with plant density so wide, like they're doing gutters, like you would do with vine crops in a greenhouse, which has its own benefits. But in terms of like using intercanopy or subcanopy, neither of them add any value versus just top light, because there's so much light penetration from the top of the canopy. You don't need to worry about redistributing it. So again, think of it this way. If you have kind of a medium density canopy, probably intercanopy is going to be best for you. If you have a very dense canopy, probably undercanopy is going to be best for you. If you have your rows spaced a meter apart, I'm Canadian, so I use metric, you probably don't need intercanopy or subcanopy. I see Tim scowling. I hope that's not at my metric system remark. It's just Tim's natural demeanor. Anyway, the message is ultimately there isn't a silver bullet. And of course, you also need to be mindful about what infrastructure makes sense for you. For some people, you may prefer having the lights off the table and hung in the canopy. For other people, you may want to have the lights not up in the branches where you're trying to work. You may want the lights down on your table, and maybe your irrigation system can accommodate that, right? Maybe you're not working with ebb and flood tables where your lights could end up underwater. Right, there's a million different considerations. Just know that there isn't generically one better than the other. They both have their place. But if I were to pick one, I would say for the way I see most people growing in North America right now, I'd probably lean towards UCL. But again, don't take that as a silver bullet of like that's what's right for you. I would strongly suggest you talk with one of our plant specialists to find the perfect thing for your grow. Okay. Now into my favorite section, and I'm going to take a breather, a little sip here. Goodness. All right. Why is this such a confusing thing in the market? Seems like there are a lot of pretty bold claims out there about intercanopy and subcanopy lighting. So let's go through some of those and talk about why I think that may be. First of all, this is something I see a lot. People say things like, ICL increased my yield by like 20% or 30%. It never comes with a caveat of like, compared to what? Compared to growing the plants in the dark? Compared to growing with no light at all? Like, what does that mean? And this is really important. This is why I keep going back to the point of saying we've done our research normalizing total light intensity. Because if you're saying I added intercanopy light and it increased my yield by 20%, it's like, well, yeah, did you add 20% more light? Because if so, that's what that does. It doesn't matter if you add it as intercanopy or top light, because cannabis is so light hungry. It's going to use that light pretty darn efficiently either way. So let's put that in an illustration. Maybe I can't do animations with the laser pointer. There it is. Okay. So let's look at the scenario. Let's say you're starting out with a situation where you've got 900 micromoles per meter squared per second of top light. And that's what I'm illustrating here. Now, this way, what we've done is we've kept that 900 micromoles of top light, and we've added 300 micromoles of intercanopy light, right? That's what you see here. That's what the legend says. So in this case, we have added light. We have added energy to that crop, and therefore this is probably going to have a higher yield than our baseline here, versus this situation right here, where we've kept the total flux the same, right? It's just we've taken the equivalent of 300 micromoles away from the top light and put it down in the canopy instead, with the intent of improving that bud uniformity, potentially preventing problem morphology, all those things I talked about, right? So again, these are two different scenarios, but they lead to two very different outcomes. And I think that's why when people say, oh yeah, ICL is so great, like it's whatever, I think it's just people adding light. And that's fine. Again, if you're in a situation where like maybe you already have a sunk cost in top light, maybe you already have some top LEDs you're really happy with, or maybe you're even still using HPS and you're happy with that, but you want to add energy and you don't want to mess with your top light solution right now, you can add intercanopy light. It will increase yield. And that's great. But just understand it isn't like this sort of magical thing above and beyond what you would get from just adding top light. Again, this kind of reiterates the same point. It's just to say that if you're adding energy, you're still in this stage of the one-to-one return on PPFD, where if you add energy, you add yield. So I'm not going to keep beating that point to death. I think we all get it at this point. Here's another thing. Talking about PPF or PPFD, the trouble with intercanopy light when it comes to research and kind of market communications like this is that, unfortunately, it makes my life harder, but I can't talk about intercanopy light or subcanopy light as PPFD. We can't make the same assumptions about it as we can with top light, right? So to give you an example, when I or a grower say, yeah, I'm growing at 1200 micromoles of photons per meter squared per second, we all understand that that means they're going in with like a quantum sensor or a PAR sensor or a spectroradiometer, and they're taking point measurements at the top surface of that canopy, right? And we all understand there is a reasonable uniformity of light at that top surface. So on average, yeah, they say they're getting 1200, they're getting 1200. We all know what that means. With intercanopy, you can't do that, right? Intuitively, you might think, can't I just go in and kind of measure, like take my sensor, put it sideways and point it at the light, roughly where my plant is? It's not really, right? And I'll take you through these pictures of why you can't do that, right? So in this first scenario, here we've got your PAR sensor, you point it at the light, and you're reading an ICL PPFD of 300. Okay, fine. But what about this? What if you take your measurement a little low, right? Or what if you take your measurement behind a leaf, or any number of things? What if you take it too far away from the light or too close to the light? Then you have a very misleading number. It could be way too high, it could be way too low, and you could be thinking that you're only adding 50 micromoles of photons to your canopy, even though over here it says 300. And then what if you have this? What if you have 3 tiers of intercanopy light and you take a measurement right here, right? So you take your measurement just as you did in this first scenario. Sorry, I need to switch back to laser pointer. Let's say you take your measurement right here, just as you did in your first scenario, and you get a reading of 300 micromoles. Well, what about the 300 up here? And what about the 300 down here, right? In this case, you have 3 times the amount of energy as you do in this situation. So again, thinking about this only in PPFD makes for a pretty misleading understanding of what may or may not actually be going on with your crop and with your light. Suffice to say, there's some math involved, but we always seek to talk about intercanopy light in terms of PPF, which stands for photosynthetic photon flux, which, by the way, is a number that's reported on all of our products, and something we can help you understand. If you're not so familiar with that metric, that's okay. again, it's just a number that talks about the total energy coming out of a luminaire versus on like a calculated plane a certain distance away from that light. Okay, and lastly, I want to reiterate that what's going on with the rest of your cultivation style or canopy architecture really makes a difference in how valuable or not your intercanopy light can be. Right, so here are some examples of things that we have seen, right? These are not pretend examples. You know, we have the first scenario, maybe someone has kind of a moderate spacing. They have their light down the middle. Here, the plants are spaced further apart. Here, the person has opted to lollipop, and then they put the intercanopy light up near the top of the canopy. Here, someone has opted to lollipop, and they put the light lower down, right? And you may look at this and be like, I would never do that. That doesn't make any sense. But you got to believe, like, there's no judgment here. People have any number of reasons why they did certain things. Maybe they could only mount something at a certain height. Maybe they were trying to manage airflow a certain way. So for whatever reason, some people may opt for this, even though the light capture is not very good, or they may opt for this or this or this. Point is, all of these really affect how valuable or not intercanopy is for your crop. All right. So to recap, making sense of conflicting advice. First of all, there are big differences between adding light with ICL and redistributing light with ICL. Some studies out there, I suspect, are normalized on PPFD rather than PPF, and other cultivation factors significantly impact the value of ICL. All right, and with that, I'm going to give you a summary slide of the whole thing. So right here, if you felt like that was a lot of information, you can't remember all of it, this is the slide you need. First of all, does ICL increase yield? The answer is yes, if deployed as additional light. However, it is dubious if deployed as redistributed light. What are the real and consistent value propositions of ICL and distributed light? And those are bud uniformity and grade. What spectrum do you use? Just follow the same guidelines that you would use for top light. And once again, if you're not really clear on what those guidelines are, talk to us or watch our past webinars. We've beat it not quite to death, but we're working on it. Why are there conflicting messages about ICL value from different providers and growers? I think it's down to the ways of executing research, especially considering planting density and PPFD versus PPF normalization. What's the difference with ICL and SCL or UCL? Again, both have a place. And should you deploy ICL? Maybe. You should consider factors like total photon flux you want on the canopy, what your planting density is, what your canopy architecture is, mounting, if you have easy opportunity to just manipulate your top light, if increasing bud grade makes sense in your market, if logistically you want to be working around something down in the canopy, on and on and on. So again, it's not the sort of thing where everybody should just go do it, but if you're a grower where it makes sense, then yes, because it can increase the value of your crop and improve your bottom line. And with that, I'm going to, first of all, thank you for your attention. And I'm going to invite 2 more members of my team to join for Q&A. So joining me will be Brian Poole, who is largely the one who executes most of our cannabis research in North America, and Dr. Jason Matlock, who, amongst other things, is our data scientist and did a lot of the analysis, especially the meta-analysis that I presented earlier. So Brian and Jason, if you could join me on screen here, we'll open it up. And
hey,
thanks,
everybody. Okay, great job. We do have a handful of questions out there, and thank you, Dave, for introducing the rest of the team. First one I'm seeing here is regarding the spectrum trials you mentioned at the early half of the presentation, where you were using BW4 with far red. I think everybody can read this in the chat, but just in case, the question was, what was the application of far red in terms of timing and duration and percentage of far red?
Yeah, okay, good question. The far red was integrated into the spectrum on the fixture. So in other words, it wasn't a separate channel where we were modulating it through the day or during the flower cycle or anything like that. The actual percent of far red in that spectrum as a factor of PFD, I think it was around 14%. Brian, do you remember?
It was actually at 50%.
Oh, that's right. Yeah, it was quite high.
Yeah, they were created for a different experiment, but we had them and wanted to implement another treatment just to see. So yeah, it was quite high in that case. But I think it was kind of interesting how didn't really see a difference in yield in that case. But if you combine, the BW4 from the ICL plus all the BW4 from Top Light, it wasn't, that much additional far red to the total canopy.
Right. And I think based on our past studies with far red, we've seen generally that cannabis is less sensitive to far red, with exceptions for certain cultivars, but in general, it's less sensitive to far red, particularly during like the flowering stage. We weren't seeing a lot of the morphological responses you'd see in vine crops or like in lettuce with a lot of expansion. Brian, do you remember, because you did this study, was there much, even just like anecdotal, was there much in terms of leaf expansion or branching or anything like that?
Not necessarily. I think a little bit of an increase in height, but the other thing that sometimes we see is a little bit of a reduction in height with ICL. So it's kind of like the push-pull of far red, with the shade avoidance response of stretch, but a little bit more compactness with ICL. But it wasn't as great. Again, like 50% far red seems like a lot, but when you think of the total photons to the canopy, it really wasn't that much far red.
Right. Good question, though. Thanks.
Yeah. Another good one here. You've mentioned that ICL, SCL may not be right for all growers or for everybody. Is there a archetype that, like, yes, this is the type of grower and the situations that should be utilizing ICL, SCL?
Yeah, also a great question. And I'm chuckling a little bit because prior to the webinar in my team meeting before this, we were talking about, is there a simple answer to this question? And it's unfortunately not really. There's not a simple answer. However, there are a couple of use cases. Like I mentioned earlier in the presentation, if you have a sunk cost in a top light, whether it's an LED system, whether it's HPS, and you just don't want to change that top light solution for whatever reason, but you do want to add light to your canopy, Intercanopy is pretty much, or subcanopy for that matter, that's a good solution in that case. Brian or Jason, do you guys want to build on that at all?
Yeah, I think first, from our position, I think we would always recommend a top light retrofit if you're running HPS. I think that's something to put out there, is in terms of best bang for your buck, dollar per photon, and overall crop response. Transitioning from a high pressure sodium infrastructure to an LED system is going to get you a substantial improvement in yield. It's going to create a safer space to work in. It's going to produce a future-proof system, and it's going to reduce your OpEx. So that's the number one thing. If you're saying, hey, I need to add light, that's the way to go. But if you're already running on an LED setup and you're working with a fixture that's putting a reasonable amount of light in, to Dave's point, right, pulling those fixtures down and replacing them with the current generation, that's a lot of change and a lot of cost. So intercanopy lighting, subcanopy lighting is a great way to increase yield in a very fast and logistically simple way. I'd also would say if you're in a market where the size and structure of your flower is a significant determinant of value, that's also another place where investing in intercanopy makes sense. As Dave pointed out, the primary change between a top light and a distributed light setup is really in that harvest fraction and reducing trim and increasing the amount of A bud. So that's a scenario where you're going to maximize the value of any given unit of biomass of harvest. If you're growing for extract, it probably doesn't make a whole lot of sense. But if you're competing in the fresh market and you're competing in a place where people can see and experience the bud, and that large, dense nug is important to the value of your business, then that would be a really great investment.
Excellent. Another question here from John. He says, you mentioned a few different areas in which growers may select ICL versus UCL and different spectra based on the cost versus yields. The question is, and I think this may be suitable for Jason because I think you've actually done some work on this, have you run economic analysis on the potential profitability of these approaches and whether or not they hold true across different strains of cannabis?
Yes. We have. And again, we talked about this earlier as we were refreshing everything. So in most cases, and again, this is largely true across multiple manufacturers of lights too. So this isn't just a Fluence thing, but certainly within our portfolio, the cost per photon of a subcanopy or intercanopy fixture is higher than its top light equivalent. So you're gonna spend a little bit more money from a capex perspective, investing in that distributed light. However, the return on that investment for even a small, we'll call it a couple $100 per pound value between a trim B grade or A grade fraction produces an ROI that manifests usually in about 3 harvest cycles. So it's something where you are going to incur a higher initial outlay of cash, but that you have a relatively short ROI, again, in a market where the difference between an A grade and other types of biomass commands an increase in value. And that, in terms of cultivar response, yeah, we definitely have seen quite a bit of variability in cultivar response. And as Dave mentioned, crop density and planting styles. So the meta-analysis that we presented, that showed some very conservative numbers, and that's a middle point, an agreement point of many different studies. But we have, I mean, I've worked with growers where we've had substantial increases well above and beyond what we saw in the meta-analysis numbers. But I've also then simultaneously had that balanced out where we saw little to no response. So just as with any change in your cultivation practice, you need to pair that cultural practice with the right phenotypes. So if you're really going to invest in intercanopy lighting, the way to maximize your ROI is to select phenos against intercanopy lighting and work with cultivars that are the most responsive. As a final note, in terms of cultivar response, kind of what I've seen is the more finicky cultivars do tend to be the ones that produce the most beneficial responses. And in one study, we worked with ice cream cake and a number of its progenitors, and that's a really tight, dense bud structure. And we did see some improvement, but much less than a MAC cultivar that we were working with, which inherently tends to form looser buds in the lower canopy. And that cultivar responded 2x to what the ice cream cake did. So it can have a huge impact.
Excellent. Appreciate it. Anything to add, Brian, Dave? All right. Well, I think we have some time for a couple more questions. This one I thought was interesting. As Dave, you had a slide talking a little bit about photo bleaching. Do growers need to be concerned with the proximity of intercanopy, subcanopy light to the plant?
In general, I would say yes, in the sense that if the light is closer to the plant, you get more efficient photon delivery. You have less wasted light. But to answer this question more in the context, I think, of what's being asked, which is about photo bleaching, also yes, but also not as much as you might think. Yes, in that you do need to be mindful of it. Like if you have a long string of LEDs on a heatsink, there are going to be red diodes on there. And if you're right up against that red diode, then you're getting a very high flux of red photons in that specific point. So logically, you would say, okay, that's probably going to point bleach whatever's right there. But what we've seen is that actually in practice, when we use something like, when we use like the 100% red, like in this picture over here, obviously that was bad news. But when we used things more like the BP6 spectrum, it actually really wasn't much of an issue. And I'll stop there and just, Brian, again, you were hands-on with this, so I'll let you elaborate on that.
Yeah, it really comes down to like a probabilities sort of thing. When 100% of your diodes are red, there's a good chance that there's going to be a flower developing right next to it. Not every flower is going to develop right next to the ICL bar. And then if, 1 in every 10 diodes on there is a red one, now you're looking at a very small percentage of those buds developing right next to a red diode. So, and you think of all of the buds in your canopy, it's a very low likelihood of them developing right in that high red environment. You can get away with a little bit more red as compared to top lighting, again, because of that, where they develop. But in general, we don't really see that. And that's kind of why we've hit that limit of the red light content in our ICL versus top lighting. Yeah.
Yeah,
Awesome.
and honestly, the little bit of bleaching that you do get from that point LED in a BP6 mixed diode array usually trims away. So you can see it on the raw plant, but once you run that through either a hand trim or a machine trim, doesn't really matter. It's almost impossible to identify the buds that were initially bleached because it's all on the sugar leaf.
All right. Maybe 2 more questions and we'll call it a day. I think this might be a good one for Brian, having so much hands-on experience working with the trials. And it has to do with SOPs and adjusting SOPs. Does implementing ICL, UCL require any additional maintenance and cleaning? I would have to think you're adding components to the grow. It's going to change your SOP. Does it become a burden or what do you think?
Yes. So we've done a few different experiments with ICL and getting used to how that gets implemented. So one of the first things is the challenge around trellising and, things like cables and hangers, how those things work together. We developed a system that made it quite easy to hang off of the trellising. And, the additional thing too is like acclimation for your plants. So, we do an acclimation with top lighting and ramp that up and then turn the ICL on. So that's something that's also going to be cultivar specific, how aggressively you can turn that ICL on when you'll mount it. One thing that was, kind of interesting was, hey, how is this going to be to work around, having light shining out into your eyes? And the way that it works too is, depending on where those tiers are and where they're placed in the canopy, it wasn't as big of a deal as we thought. And, we're wearing glasses anyway. Again, you're getting so much more light from top lighting that the light coming from ICL, even though it's at eye level, is not that hard to work around. We do a standard clean of the materials between every crop cycle. One thing that was kind of interesting was for the spectrum experiments, we were using a, more of a kind of a production style module, not purpose-built ICL. And it wasn't as hard on those light fixtures as we had anticipated. It wasn't a simple kind of clean down with the rest of our sanitizing and the room turnover was enough to, keep those going from cycle to cycle. So there's going to be some slight things to add into your SOPs, but nothing, nothing too major. Once you find a way that you can, hang these and keep them, more or less accessible, without having to take them down completely between crop cycles, and that's going to be different for every operation. So we can't say it's a one size fits all solution, but we can definitely work with you to say, hey, here's what we've tried. This might work for you.
All right. You know what? I actually think that'll be our last question for today. Guys, I appreciate you all coming on and speaking to the group today. All of our attendees definitely appreciate you guys stopping in. Hopefully you learned a lot. As I mentioned at the beginning of the session, within the next, say, 48 hours or so, we'll be publishing this out, generally put on YouTube. If you registered via the event link, you should also get an email with that information once it becomes available. Otherwise, again, yeah, thanks for the applause. Really appreciate everybody's time. You can always contact us through support@fluence-led.com. Of course, you have all of our speaker information on the screen. You can generally find them on LinkedIn. And look forward to more webinars throughout the year. This was our first of 2025, and we're excited to bring you more fresh and exciting content in the months ahead. So again, thank you, and we'll see you soon.